Hello everyone, and this is the video for the 3 opening examples for section 5.2. So when I'm gone here, I would like you just to watch this, and hopefully it's a good overview before you try any problems on your own. And the whole goal of these problems is to simplify them down enough to either get to a single trig function or so you can no longer simplify in any way. And yes, it is easier said than done at first. It definitely takes practice. I would say, like anything, you're not good at it unless you practice it on your own quite a few times. So if in some ways today you're frustrated with the material, don't worry, it'll get easier with time. But I hope that these videos will help you. So first, let's take a look at number 1. And the goal of all of these is to use our algebra skills to see if we can simplify this at all. What I notice first is that these two terms multiplied cannot be combined with this term because they're unlike, because they have different exponents, so I can't add. I don't need a common denominator because I don't have a fraction. But I do notice that in both this first term and this second term, I do have some sort of sign that I could take out. One of those things, like I said in trig, when in doubt, draw a triangle. Another one is whenever you're not sure or when in doubt, factor it out. So if you take a look at the problem, I notice that there are 2 signs here and 4 signs here. So we're able to take out 2 of the sine x's, and then we are left with, so sine squared x out of this whole term is just left with cosine squared x, because this divided by this is 1, plus, if I take 2 sine x's out of 4 of them, I am left with 2 of them. And so after I took out the GCF, I take a look at what's left over inside the parentheses. Now, you might remember that there is a Pythagorean identity that's sine squared plus cosine squared equals 1. So I'm going to write this up here on the top. Sine squared theta plus cosine squared theta equals 1. So this entire expression can be replaced just with 1. That is multiplying sine squared x. So your answer is just sine squared x. We reduced it to a single trig function. The second example, I'm going to ask myself similar questions. I'm going to first ask, can I treat number 2 like number 1? Can I take out a greatest common factor in the top? Well, sine and cotangent in one term, 1 in another, no, I can't. Can I combine any like terms? No, these are unlike. Well, I do have a fraction, so I could get a common denominator if there were 2 fractions, but there's only 1. So notice that the 2 top pieces share the same denominator. Like, if I have something with just numbers, 1 plus 5 over 2, that is the same as saying 1 over 2 plus 5 over 2, because they share the same denominator. In the same way, I can take this function and put both pieces over the same denominator. Now, before I do that, this should actually say sine of x, cotangent of x minus 1. Sine without an angle is sin, correct? If you remember that from the beginning of Unit 3, it would be quite lovely if I'd follow my own advice and put an angle on sine, because right now this means nothing. So just a good reminder for you and for me for future teaching to change this on my worksheet. So anywho, back to the problem. If I take this problem and rewrite it something like this, we are saying that sine of x cotangent of x is over cotangent of x minus 1 over the same denominator of cotangent of x. It's quite handy-dandy here because my cotangents cross out, so I'm left with just sine of x minus 1 over cotangent of x. And I don't know about you, but I don't really like it written like this. It doesn't seem as simplified to me. So what is 1 over cotangent the same as? Why, yes, it's the same as tangent, because this 1 over cotangent is the reciprocal function to tangent. So I can replace this with tangent of x, and so my final answer would be sine of x minus the tangent of x. I can't combine like terms, and I simplified this as far down as I possibly could go. The last example here, number 3, I'm going to ask again myself the same questions. I don't have a fraction, so I can't complete it like number 2. I have multiple terms, so let me see if I can take out a greatest common factor. Well, I have cotangent, secant, and cosecant. And none of them are like, so I can't take out a GCF. Again, none of them are like, so I can't add any like terms. So I picked this example on purpose because this is when I usually, if a denominator thing doesn't work, if a GCF doesn't work, I start to replace things that I know are true. So for instance, I know that cotangent is really the same thing as cosine of x over sine of x. And I know that secant, I like cosine more than secant, I know that that's the same as 1 over cosine plus cosecant of x. I'll leave that go for now. But these were not like terms, but now when I convert them, I notice again that my cosines cross out diagonally because I'm multiplying across. So this is really 1 over sine of x plus cosecant x. And again, if I'm trying to get this as simplified as possible, instead of writing this as 1 over sine in a similar way to this problem, I can write this as the reciprocal function cosecant x plus another cosecant x. So I think the best answer, now that these are like terms, is I have one of them plus another one. So my answer is 2 cosecant of x's. Okay, so those are the 3 examples, but I think that's something that will help you in the problems to come. If you could fit this on the top of your sheet in this area, I'm going to write something on the next slide that you might want to write down yourself. Let me skip ahead to a blank page here. So there's going to be times when you're left with something like this as your answer, cosine squared x minus sine squared x. And you want to simplify that completely because right now we have a cosine and a sine in the problem, and we usually just want one trig function as possible. Now up here, I'm going to write down the Pythagorean identity, sine squared x plus cosine squared x equals 1. What I want you to be aware of that this is not the same as this, because only when you do sine squared plus cosine squared do you get 1. So this is not 1, unfortunately. So here's what I want to point out to you. This identity you can manipulate to help you. For instance, what if I wanted this entire expression all in terms of cosine? That means I'd need to get rid of the sine somehow. Well, from up here, if I wanted to get sine squared alone, I would just have to subtract cosine squared over here. So you could say that sine squared x is equal to 1 minus cosine squared of x. So if you wanted this all in terms of cosine, you would keep the cosine squared x in front, but then you would replace sine squared x with this, 1 minus cosine squared x, and then you could distribute the negative, get cosine squared x minus 1 plus cosine squared x. So you'd have cosine squared x plus another cosine squared x. So you'd have 2 cosine squared x minus 1. If I wanted to do the same problem again, but instead I wanted to get everything in terms of sine, not cosine. If this was what I was given as my answer, or this is how far I got in the problem, and I knew that I wanted to convert everything to the same trig function, you could use this same idea. From this original function, you could say that cosine squared x is equal to subtracting the sine over here, so equal to 1 minus sine squared of x. So in this expression, if you would like to, you could take this cosine squared x and replace it with 1 minus sine squared x. And then you still have this other negative sine squared x. So you have 2 like terms. So this one, another way to write it, would be 1 minus 2 sine squared x's. So just be aware, later on the worksheet you're going to be doing, or pretty soon actually, there's going to be some examples where you need to recognize that this Pythagorean identity can help you do some substitution, so you could get it completely in terms of cosine or completely in terms of sine. Feel free to watch this again later if it helps. So guys, this is the end of this video. Now is the time for you to try the rest of the worksheet on your own, and the other video will be made available to you probably in the last 30 minutes of class. All right, thank you.